Yes, good morning, everyone. This morning, we are going to be talking about halogen. Halogens was family, and then when you're talking about halogen families, there are group 7 elements. There are group 7 what elements, and what are they, and why are they group 7? Why are they group 7 elements? We have it's comprised of fluorine, which is we have chlorine, I think that's 17. Then we talk about bromase, then we talk about iodine, then we talk about astatine, which is the last group. Therefore, we call them group 7 element because when you look at this particular thing, you have to write the electronic configuration. If I draw the electron share for fluorine, I want to share 9 electrons. I've given out 2, then I have 7, you see. This 1, 2, 3, 4, 5, 6, 7, 8, 9. Therefore, when you consider this valence electron, this valence shell. Now, when you consider the valence shell, we have how many electrons on the valence shell? We have 7 electrons. It has 7 electrons on the valence shell. These are valence electrons. Therefore, because it has 7 on the valence shell. So it belongs to group 7. And also, they are very strong electronegative element because they need only 1 electron to fill this particular orbital. Because this particular shell, I talk about this particular shell, it's called L shell, and it must take 8 maximum electrons. However, it has 7 already, need only 1 to become filled up. Therefore, if you use SPDF, 1s squared, 2s squared, they have 2p, 9, 5, yes. You discover that this and this the same energy level. N equals what? 2, which is the principal energy level. Therefore, the electron on that particular energy level is 5 plus 2. Which will give me what 7 belongs to what group 7 element. Then block. With this, you can get your block P, and you can get the period. The period was 2. Therefore, basically for fluorine, outside group 7, it has block P's, and the period was 2. And I've told you, and they are non-metals. Why do they say they are non-metals? You need to know that they are non-metals because they ionize by gaining electrons. They only need 1 more electrons. And if you supply the 1 electron next, it will become E minus. Minus means it has gained 1 electron. Therefore, in this particular case, the electron to be shared will have been from 9 plus 1, which will have given you what 10. Therefore, in this case, you have it like this. Therefore, we say deionized by gaining electron. Yeah, these are the basic things that you need to know for us. And another thing you need to know that is they don't occur freely in nature, but in combined form. You don't see them freely, Likewise, we have love to see them like this in there because they are gas. I would love to see them like this. This is their state of matters. Always like this. Then everything is always like this. Yeah. But they don't exist freely in nature. You don't see them like this. You only see them in a combined form, like H, hydrogen fluoride, like sodium chloride. You see them like this, or potassium iodide. You only see them in a combined form. This is what we call a combined form. Therefore, you either see them in a combined form. They don't normally exist as a word free. You don't see them as a word occur freely, free in nature. You don't see them occurring freely in nature. Therefore, when you want to see them, you see them in a combined form. Therefore, basically, what I've been talking about, I've told you that the halogens They are group 7 elements. Why are they group 7 elements? Because they have valence electrons. They have 7 valence electrons. You understand? The outermost shell. I've told you the member of this particular group, and I've told you that they are non-metals. Why? Because they are ionized by gaining electrons. I've told you that you don't see them freely in nature because most of them are very reactive, and those that are not reactive, they are less and moderate reactive. Therefore, you don't see them freely in nature, but you see them in a combined form, just like when you have salts. Okay. And fluorine is the most reactive element in the family because when you look at fluorine, the atomic size is smaller and it's closer to the walls, to the nucleus. Therefore, the force of hydrogen the nuclear charge is stronger and is to draw electron to it. So, when you look at it, automatically this is the center, everything will be drawn towards the center. You need only one electrons. And when you consider this now, when you consider chlorine, chlorine is 17, you are going to have something like this. This 2, this 8, making 10. Then the last one will take 7. Yes, the last one will take 7. Fine. You discover that yes, they are having both 7 7 in the water in their valence shell, but the numbers of shell here is 3. Therefore, this to the valence electron is far. When you compare, it's far away from the one. The valence electron to the nucleus is far away. Therefore, the nuclear charge is a little bit far away from the center. Meanwhile, this is closer to the center, and that brings more electrons. If you have just one electrons, this gets more attracted to this particular one, to this particular valence shell, or to this particular nuclear charge. Why? Because the atomic size is smaller. Therefore, as you are going down, the reactivities of this particular family goes down as well. Therefore, this will be more reactive than what? Chlorine. Chlorine will be more reactive than what? Bromine. Then bromine will be more reactive than what? Iodine. Then towards aspartame. Therefore, what we're saying here is the same way. Say fluorine is the most reactive element in the family. Why? Because of the atomic size smaller when compared with others. And the nuclear charge here is stronger when compared with others. Then aside that, we say bromine, iodine are chemically very similar to what? Yeah, they're going to be similar because what happens is they have the same valence electrons in their outermost shell. But aspartame is totally different from other because it is a radioactive element. And when you're talking about radioactive elements, you'll be talking about what do we call it? Nuclide, because the nucleus of such elements is not stable. When you consider their neutral to proton ratio, consider the neutral to proton ratio is not what? Is not stable. And if it is not stable, automatically the atom can spontaneously will disintegrate to form another atom. Therefore, it does not occur naturally. Okay, good. Then we move to the next one, which is the electronic configuration and the properties of this particular halogen. For the electronic configuration of halogen is one of the talk about is one electron short of noble gas structure. Yeah, each atom of this element completes by either gaining or sharing electrons. You know what we're talking about here, either gaining or sharing electrons. Therefore, basically, when you have 19, it's like this as gas because they are not metals, mainly gas. And you have 9 here, you have this. If you do the electron share, you have this. Then I draw another one line, we have this. needs one electron, it needs one electron. It cannot transfer. If it transfer, it will not get what it wants. It cannot what transfer. What they can do is to share the electron. They now share what electrons. When they share the electrons, what happens? Become complete. You cannot have them like this. You can have them like this. One will give this, another one will give this. Therefore, here you have 1, 2, 4, 5, 6, 7. Here you have 1, 2. Then here you have something like this already. Here 1, 2, 3, 4, 5, 6, 7. Therefore, in this case, the form called that is flowing with gas. This sharing electron, and they can equally gain electrons. In that case, you can have, let's say, you can have sodium chloride. And for example, you can have sodium chloride. Sodium is what 11. Then you do the electron share. Take 8, then you have 1 more. Meanwhile, the chlorine to 17. Okay. Yeah, this one has 1. You need 7 to become complete to make 8. This one needs 1 to make 8. What will happen? This one will decide to transfer electrons to this. Can decide to transfer 1 electron to this. And this is group 1. Sodium is in group 1. You need to understand that, while chlorine is in group 7. When it does that, what happens? Sodium becomes plus. It has lost 1 electron. If sodium has lost an electron, the electron share will have become complete now. It will become what? 10. See, then what happens to the chlorine? Chlorine will have gained the what? The electrons will become 8. Both of them will now be very happy on that journey. Okay, then you have this, then you have turned to 1 for what sodium to become Cl minus. Therefore, when both of them combine together, they combine to form of sodium chloride. And that is what we're talking about. Gaining 1 electron usually from group 1 and group 2 to form a univalent negative ion. As you can see here, this univalent unit means what? 1 negative ion. Okay, then we quickly move to their general properties. Okay, talk about their general properties. We say 1, they are diatomic molecules. And why are they diatomic molecules? Because you can only see them as 2, because they are gas. Because their state of matter is gas, you can either see them in this, you can see them in the, that's what we mean by diatomic molecules. And aside this, say they have low melting and boiling point because they are sharing electrons. So when they are sharing electrons, yes, they are sharing electrons to form that particular thing I talked about. They have to share electrons between each other for you to have Fe2. Therefore, sharing electron means covalent compound, and for the covalent compound, they have low melting and boiling point, and they are only soluble in organic nonpolar liquid. They are not soluble in water, they are soluble in organic nonpolar molecules. At room temperature, what happens? Yes, there's a problem at room temperature because you have the fluorine, which is 9, we have the chlorine, which is 17, then goes to bromine, then goes to iodine. At room temperature, this and this, they are gas. And why are they gas? Because of what we call the van der Waals force. There is a weak force that's combining this, that is making this particular family to become solid or liquid. And this particular van der Waals force in fluorine, it is very, very weak. That is why it won't be too easy for fluorine to become solid or liquid. But when it comes to chlorine, it becomes weaker, is increasing, the van der Waals force is increasing. Van der Waals force. Van der Waals force is a weak force that makes a gas to become solid or liquid. Therefore, in this particular way, and this van der Waals force increases as their what? Atomic number increases. As the atomic number increases or the molecular mass increases, the van der Waals force. Atomic number increases. As the atomic number increases, the van der Waals force increases. Therefore, here it becomes easier for you to easily liquefy what? Chlorine gas. The bromine becomes so heavy. That's what we're saying. And when it comes to it, they become heavier. Therefore, in this particular case, we are going that the van der Waals force is increasing. And what happened to their boiling point? Boiling point will start what? Increasing, because they begin to have a tendency like bromine now. Like for bromine now, I say it is what? Liquid. Now when you now come to everything, you say it is what? Solid. Therefore, here, the van der Waals force is higher when compared to what? Bromine in that particular what? Order. Therefore, at room temperature, fluorine and chlorine are gases, while bromine is solid, bromine is liquid, while it is solid. And the boiling point increases down the group. That is, the boiling point increases and their molecular mass increases. Then they are colored. Why are they colored? They are colored with what? A typical penetrating what? Odors. The color dipping down the group. As we are moving down the group, the color is becoming what? Increasing. Therefore, for chlorine is pale yellow, while for fluorine is pale yellow. It's pale yellow, while the chlorine is greenish yellow. See, bromine is reddish brown, while the iodine is purple black. So as you are going down, the color is becoming thicker. Therefore, from pale yellow to greenish yellow, then from to reddish brown, which is bromine, then iodine to what? Purple black. Okay, good. Sorry, purple black. Purple black. Sorry. Yeah, but this is due to the what? Absorption of what? Radiations, because it's due to the absorption of radiation in the visible region, which results in the excitation of what? Hotter electron that will call valence electron to higher energy level. By absorbing different quantum of what? Radiation, they display different colors. We need to understand that this is due to the what? Absorption of what? Radiation. When you're talking about radiation, we're talking about energy. This energy is from what? Quantum in the visible region. And it is this that results towards, but by the time they absorb different quantum of radiation, they move it from what higher to lower, give them different color, and make them to display different color. Please note this. Okay, good. Then move to the next one. Which is what we call their what? Reactivities decreases on the group, which I've told you about, that the fluorine is more reactive because the atomic size is smaller, the nuclear charge is higher. Then the reactivity suite such as volatility, solubility, electronegativity, oxidizing ability, and the tendency to enter into chemical reaction. This is what we're talking about reactivity series. Volatility, fluorine will be more volatile than chlorine, chlorine will be more volatile than bromine, bromine will be more volatile than iodine. In terms of electronegativity, the same thing. And this gradation in properties due to the increasing complexity of the atom as the atomic number increases. Because as the atomic number increases, what happens there? The van der Waals force increases, the atomic size increasing, so many things coming, and that's what decrease their that will decrease. It will not increase, it will decrease their what? Reactivities from what? From higher, from fluorine to iodine. And all halogens dissolve to some extent in water. Yes. Fluorine reacts vigorously with water to produce, please you need to know, oxygen and what? Hydrogen fluoride. They are all strong oxidizing agents. You know what we mean by strong oxidizing agent? Anything that undergoes oxidizing agent, we call it reduction. And when we're talking about reduction, we're talking about gain of electron. They have a high tendency of gaining electron because in their valence shell, they need only one electron. Fluorine oxidizes water to one peroxide. Therefore, chlorine reacts slowly with water to give oxochlorate 1, very important acid, oxochlorate 1 acid. And the oxochlorate 1 acid decomposes to give hydrochloric acid and oxygen, very, very important. Automatically, what we're saying is when you have water you pass it through what? Chlorine gas. What will give? It will give ACl plus also chlorate 1, which is what we call HCl, HL, ACLO, that's also oxo-chlorate 1 acid. This oxo-chlorate 1 acid will now decompose to give hydrochloric acid and oxygen. Then they all combine readily with most metals except gold, platinum, and titanium, and non-metals except oxygen, carbon, and nitrogen to form ionic and covalent compounds respectively. Therefore, you can have sodium from sodium what? Halide. So that if you have chlorine, sodium chloride, then with phosphorus as well to form what? Phosphorus what? Halide. Therefore, whereas this non-metal, this metal. Therefore, they both react with what? With halogen to form ionic and covalent what? Compound, respectively. Therefore, note, under certain conditions, the less reactive halogens react more vigorously than what? Chlorine. The less, that is under certain conditions, the less reactive halogen like bromine, like iodine itself reacts more vigorously than what? Chlorine. For example, bromine is capable of what? Corroding gold because it is a liquid, you see, and has more concentration than chlorine, which is a gas. That's what we are saying, because when you are liquid, it can easily move around the whole surface and what? Corrode the metals, unlike gas. Therefore, for example, bromine is a liquid. Bromine is a liquid and is capable of corroding what? Gold, because it's a liquid and it has more concentration than what? Chlorine, which is a gas. And they combine with hydrogen to form gaseous covalent compounds of formula H. Yes, X. The halide ion has the oxidation state of what? -1. What we're talking about here is very simple. You can have ACl. Automatically the oxidation number of chlorine become minus, because this is 0, you have 1 times H plus 1 times Cl equals to 0. Automatically you have 1 times plus 1, which is then plus what? Cl equals to 0. Automatically Cl equals to 0 minus 1. Then Cl equals to what? Minus 1. Practically what we are seeing here is going to have the oxidation state of what? -1. Then another thing we need to understand here is they react with silver to form silver what? Halide. This is very, very important. They react with silver to form silver what? Halide. Only silver fluoride is soluble. Silver what? Fluoride is soluble. Silver what? Chloride is white, while silver bromide is pale yellow, while silver what? Iodide is bright yellow. But what we are saying here is only silver fluoride is soluble. Therefore, for silver chloride is white, bromide is pale yellow, while the iodide is what? Bright yellow. These characteristics can be used to test for what? Halides. You can use this character automatically when you have a silver, you pass them through what? Through chlorine or through halogens. If it is passing through chlorine, it forms silver chloride, which is white. If it is bromine, it forms pale yellow. Then, if it is iodide, it forms bright yellow. You have asked me what happened to the word fluorine. It's explosive, it's more reactive. Therefore, you cannot actually carry out that in the lab. These characteristics can be used to test for what? Halides. They all react with sodium hydroxide to give a mixture of what? Halide salt and oxochlorate 1 salt. Please, you need to understand it, especially when they are diluted and concentrated on. But for this, you have the chlorine gas reacting them with sodium hydroxide. They form a mixture of the halide salt, which is sodium chloride, for example, then oxochlorate salt, which is sodium oxochlorate 1. sodium also go with 1 and water. Please, it's very, very important. Automatically, when you add them with a base, are going to form 2 salts, sodium chloride and what sodium oxochlorate 1 salt, or sodium oxochlorate 1. Then more reactive halogen display, that displacement reaction, less reactive halogen from their salt. Automatically, if you have bromine, then I have potassium iodide. This is sort of what halide, but this halide is iodine, and bromine is higher than what iodine in their words. So automatically bromine will display iodine to form potassium bromide and what iodine gas, or iodine what aqueous. Then this how the halogen reacts, how the what halogen react with what halides. Told you that when chlorine water, this chlorine water, a solution of chlorine, chlorine water is added to a colorless solution of potassium what bromide. This potassium bromide, what happens? The solution turns what, as you can see, the solution turns what orange as shown. Very simple thing, displacement reaction. The potassium bromide is a colorless solution. By the time you add what aqueous solution or what chlorine to it, the colorless solution will turn what orange, meaning chlorine is what higher than bromine. Therefore, the chlorine will display bromine to form its salts, from what potassium bromide to form potassium chloride and what bromine, which is what we are seeing here. Therefore, bromine has been pushed out of its compound or display, or a display or reaction. And then when chlorine water is added to a solution of potassium iodide, what happens? The solution turns reddish brown. The same thing, because chlorine will display what iodine to form what reddish brown solution. Therefore, this time iodine has been what displayed. Therefore, the higher one can display the lower one from their source.